So we not only can fly to the moon, we have the first ever lunar distance network that's fully commercial as a necessity because you have to build it all commercially. So quite innovative. And so we're very excited about that mission.
Welcome to Forging the Future. And there isn't anything that screams innovation louder than space, although you can't, in space, no one can hear you scream. So, but I'm here today at NASA filming with Steve Altemus, President and CEO of Intuitive Machines. And Steve, welcome to the show.
Pleasure to be here, Chris. Thank you.
I'm really excited about this mission briefing we're going to get today. And also, really full circle, I interned at IBM FSD at NASA 40 years ago during the shuttle days, and it was when they built this building. So it's like old home week for me to be back and excited to be here with the show. So you were just 6 years old when Neil Armstrong made history, right, in 1969, becoming the first human to land and walk on the moon. How were you inspired by that?
Well, I don't quite remember being 6 years old, but
Yeah.
my first inspiration about space really came when I was going to study aeronautical engineering at Embry-Riddle Aeronautical University. And as I was walking across from the engineering class across to the university center, the Challenger mission went up off of Kennedy Space Center. As I was walking across, I saw it climb, and then break into pieces and explode. And two boosters went off into this kind of trident shape. And I knew at that moment that we had lost it. And I went into the university center, and it was on CNN at the time. And they were saying, we're looking. And they were calling for it. I said, it's gone. And I didn't realize at that moment, my fate, my destiny was to end up working in the space program and working for NASA. And I spent 25 years in NASA human spaceflight, the last 10 of which I was the engineering director at Johnson Space Center, leading human spaceflight engineering for all human spaceflight programs that came through Johnson Space Center. And actually retired from NASA to form Intuitive Machines as a deputy center director of Johnson Space Center.
Well, to bring that even more full circle for me is that I was here during that exact moment.
Oh, wow.
I was working for, like I said, IBM. I actually was written a program that they were going to use on the Teacher in Space mission that Krista McAuliffe was on Challenger during that time, and watched that launch and that accident happen in the lunchroom here in the FSD building, which is now Boeing, right?
Yeah. And then now the former IBM, now Boeing building. That's where we are today, right? Except the top floor, sixth floor here is Intuitive Machines.
You're right. You're the top dog here now. But it's just interesting how the paths of life take you. And I didn't know that story before you just told it. And it was definitely a dark moment in space history for the shuttle program. But we've come a long way since then.
Yeah, if I could comment on that, one more kind of unique moment was that many years later in 2003, we lost the Columbia coming over East Texas, and it broke up. And from my perch at the time was Kennedy Space Center, I was asked to lead the reconstruction of Columbia, and so put all the 85,000 pieces of debris back together and determine what the forensic cause of the accident was. There was a huge team, and our piece was studying the debris to look at the forensics. And so from my days at college at Embry-Riddle Aeronautical University, seeing that and then having to participate in another major accident and help NASA recover from that. And that was actually a launching pad for moving to Johnson Space Center to come lead and run engineering at Johnson Space Center. So it kind of is all tied together in a way.
But you'd chosen aerospace before then. Was there anything behind that decision? You were going to really for aerospace as aerospace engineering?
Well, when I went, I left. I come from a construction family. If you look in the background here, it's Bethlehem Steel.
Mm.
It was funny because my parents were from families that one side of the Bethlehem Steel plant was during World War II was making ordnance, and the other side of my family, the other, was making armament.
Mm.
And whoever, if the ordnance pierced the armament, then the ordnance group got bonuses, and if the armament withheld, then they got bonuses. And so World War II family, Bethlehem Steel family, it was all construction. And I was one that broke out to say, I want to go fly jets. I want to go fly airplanes. And I went to the Harvard of the Skies, which was Embry-Riddle Aeronautical University. And at the time, they didn't have an aerospace degree. So I got an aeronautical engineering degree to learn how to design and build aircraft. And from that, I immediately went into helicopters, and then I went to Boeing helicopters when I had an opportunity to go to NASA. And that's where I became an aerospace engineer.
And how was that? Any cool projects while you were at the university program that you remember?
Yeah, we had no computers.
Really?
And our design projects were a detailed design of, first a general design of an entire aircraft and drawings, old blueprint drawings, pencil drawings. And then actually do a detailed design of a component like a wing, horizontal stabilator, those kinds of things. And so those were very enjoyable. Taught you drafting the old way, taught you how to do blueprints and then also how to do design.
But yeah, no, people don't remember. Like when I was at IBM 40 years ago here at FSD, which was the Federal System Division, they had the first IBM PC for the entire department. Right. There weren't computers on every desk.
Yeah,
right?
There was no desktop PC.
Yeah, but we're still launching things to space and designing and engineering without, having the individual workstations. There's 3270s and some of those like terminal-based computers, but nothing like people think about today.
Right.
I wanted I saw mission control in there, which is super cool. With the people sitting in the ring and everyone testing out the Lunar module that you're working on, but people forget that you just didn't have the computer power that they do now, or that the first lunar lander had like the equivalent of like a TI calculator or something like that as far as power, right?
Isn't that crazy? When the Apollo program started, there was no computer. There were people and slide rules and hand calculations on a chalkboard. And then MIT had to build that first computer, right? And invent it. And now, that's one of the reasons we can have a company that aspires to go to the moon, fixed price, in the time it takes to get an undergraduate degree. And you can do that standing on the shoulders of everybody who's built all this technology and invested in this technology over the years. So now we can buy technology off the shelf that can go to the moon.
Right.
And that's what gives us the advantage at this point.
Do you have an internship program, or do you use interns?
Oh my God, yes. They're just so bright, and their minds are so elastic. We have interns come, even from day one. We had, if we had 30 people in the company, we would have 10 interns in the summer, right? And we'd put them with somebody and we'd train and we'd have them back again and again. Now we've gone even well beyond that. So we do internships with San Jacinto Community College. So we build a curriculum to train aerospace technicians, give them certification degrees or certificate degrees, machining, electronics, composite materials, those kinds of things. They come out of the Edge Center up at the Spaceport Houston. We give them an internship. And then if they work out, we hire them full time. Now I've worked with San Jacinto Community College to extend that. So those who went through that program and were interns for Intuitive Machines, now Intuitive Machines does tuition reimbursement for their engineering technology degree to get their first associate's degree. So we're really trying to grow the workforce in this area and really touch labor, right? We need touch labor. There's a shortage of that. And so aerospace quality, touch labor is where our focus is. We get a lot of the university partnerships that send interns here too. It's from all over the country, actually.
I think a lot of businesses think interns are heavy lifting and you're bringing in like a high school student and having to mentor them and have a whole internship program. What I really liked about the IBM co-op program at the time was they treated me just like any other engineer. You know, I was sharing an office with a guy that had been at IBM for 40 years, right?
Yeah.
I was assigned projects to actually make, and actually being like the only coder on that project. And learned by doing, right? And it's not like I had someone like actively mentoring me. Is that similar to your experience? I mean, you have what, 11,000 people in NASA that are employed here.
For me, since NASA, we had Johnson Space Center, we had over 12,000 people.
12,000.
And, I would have 30 interns in engineering directorate, which had 900 civil servants and 2,000 contractors and 30 interns. That doesn't seem right. As Intuitive Machines now, we bring them in and we put them to work. And all the feedback I've gotten from the intern program at Intuitive Machines is, wow, I'm actually working on a lunar lander. I'm actually working on software that's going to go and help this thing land on the moon softly. They have an incredible amount of responsibility. But the internships are they're about the people, right? But they're also about the university relationships. So because we have programs to bring in the university students at the undergraduate level, the master's level, PhD, and share faculty, now we have a relationship. So it's back to the way it used to be in Apollo, where there was strong R&D, research and development going on in the universities, and federal dollars would flow through NASA to universities. We do that same model where Intuitive Machines has a relationship with over 15 different universities where we're reaching into their faculty and their students to get real products out of them that go into our missions. I just see that model as was very effective back in the 60s, and we lost it here in budget cuts and everything over the past decades, where that R&D funding has dried up. So I've kind of took a page from history and applied it to Intuitive Machines.
I love to hear that. And I imagine that people scramble to get into that kind of program because so many other places, as an intern, you end up being a copy jockey. They don't know what to do with you because they're not actually treating you like you can contribute,
Yeah, well, you see the light go on in an intern's, you just see the light bulb go on over their head when they're actually like, oh my God, I can actually work in aerospace. I can actually see a career. I could see myself being a world-class engineer. Even the technicians that we bring in from the Edge Center at San Jacinto thought it never work on a space program. Didn't think they had it in them. And now we see their confidence level go up. I can do just about anything. Their imagination explodes. It's just fantastic.
So Steve, you're pushing the lunar exploration through Intuitive Machines. I mean, how did that get started? What's the mission behind the company?
Yeah, a very interesting story about how we ended up as a company here in this time in history with the mission that we have, so I'll explain. So I was working in engineering, leading engineering for the human spaceflight programs, and I was responsible for developing the next program architectures for human spaceflight. Essentially, how do you get humans off the planet in an overly constrained environment, right? With the political biases that there were, or the different stakeholders that there were, there is no pure physics solution that you can come up with that meets all the stakeholders' needs. And that's what I was asked to do as a space architect, was come up with a program that would meet the congressional needs in terms of how much they could appropriate, meet the expectation of the executive branch, which said, I need something quickly. And, so within budget, quickly, overly constrained, and
safely.
By the way, the moon is out of favor. You're not allowed to go back to the moon at the time because we had been there, done that, and we were a capabilities-driven architecture is what they had, which is do all the technologies you need to get to Mars. So they come in and create a new, the Constellation program was canceled. That was the moon program in NASA at the time. And they said, come up with a new idea. So they gave me the Human Exploration Framework team to build, which was how to make decisions in space, on-ramping commercial space And what do you do with the remnants of constellation to create something? So I came up with that and said, hey, you can't get rid of all the remnants of constellation. You need that. You need Johnson Space Center, and you need mission control and mission operations. You need Huntsville and Marshall Space Flight Center. And if you cut Space Launch System and Orion, you'll lose those centers and you'll lose human spaceflight for decades. So rather than we see the SpaceX commercial space coming on strong, but slowly, it wasn't quite there yet. So to take all our eggs out of the basket of human spaceflight and the traditional programs with big aerospace and give them to this, quote, startup called SpaceX seemed premature. And so my decision was, brief to the administrator, you got to keep SLS and you got to keep Orion and you got to keep them moving at the time. So then they said, well, you can't go back to the moon. What are you going to do? So we came up with another thing that said, go to, we called it the Waypoint. Today it's called the Gateway. And it's an orbiting station in a near rectilinear halo orbit that was not to go to the moon, but would allow, as a stepping off point outside the gravity well of the moon, allow international partners to go down to the surface because they still wanted to go to the moon. It allowed us in the United States to explore deep space. It was actually an electric propulsion spacecraft, space station that could go out 1 million miles out to the Earth Sun Lagrange points and then back to the moon. Mm. It would teach about long duration space flight. It would teach about flying beyond your ability to abort to Earth right away. You'd have to fly out into blackout periods, much like trying to go to Mars. And yet it still preserved the moon as a potential opportunity to go forward. Put that in place, talked about that, sold that around the world, went to all the different, we did that under the International Space Station Collaboration and Consortium. So talked to all the countries and convinced them that this was an essential compromise if we were going to move forward. And I came back and I was told, no way, we're not doing that. So I was very frustrated.
Why did they say no? I mean, do you think?
Because there was no appetite to build a gateway around the moon. It was just, there was no interest at this time, 2010, 2012 timeframe, to kind of think about the moon at all. And so we're not doing that. So I went off and formed this project called Project M, which was to take, this was a rogue project inside of NASA, to take a liquid oxygen, liquid methane lander, because we in engineering were pushing liquid oxygen, liquid methane cryogenics, build a lander, put a walking robot on a lander and fly it to the moon in 1,000 days. Overly constrained, super tough problem, advancing technologies on many, many fronts, and do it with no real appropriations. And the team said, yes, we're go. You know what we did? It turned into Project Morpheus, but we built a liquid oxygen, liquid methane propulsion system on a lander that was an Earth-based lander, and we flew it 37 times. We lifted off, we flew it across at Kennedy Space Center and landed in a simulated lunar base at the end of the shuttle landing facility. We observed how the dust plumes came up and how the instruments were occluded, navigation instruments got occluded by the dust and still landed successfully. We proved out that you could light and relight liquid oxygen, liquid methane engine, and we determined how to land with precision and avoid hazards. Huge technology breakthroughs. And in addition to that, we built a walking robot and we launched it to space station, and it cleaned ductwork on space station. Didn't know all of that was possible. Actually, the robot on space, tending space station, was written about by Isaac Asimov.
Oh, really?
And I didn't know that science fiction had written about it before we had gone and done it and proved it out. I just find that interesting. But out of that, we actually, through sheer force of will, imagined that whole program into existence within a large bureaucracy.
You were an entrepreneur at that point.
That's right.
Mm-hmm.
And so when there was no real motion inside of NASA on where we're going and no destination, I said, it's time for me to go figure out what else to do. And so I came up with a concept called intuitive machines, which was going to serve energy, medicine, and aerospace, because I was in Houston. Step outside the gate and begin where you are, is the way I thought about it. And it wasn't until 2018, We started in 2013, and we had 25 inventions in the first 5 years: oil and gas, energy, healthcare, and aerospace. Long-range drones, 1,000-mile over-the-horizon fixed-wing drones.
So you were doing more industries in the beginning
Yeah.
of Intuitive Machines? Okay.
And then in 2018, the National Security Council and the National Space Council came through and said the moon is of strategic interest. We are essentially in a competition with China to land on the moon. And whoever holds the high ground on the moon sets the norms and behaviors in space. And so they said, put NASA at the point of the spear and use soft power and have NASA ignite the U.S. economy and show how the U.S. economy can demonstrate its technical prowess and commercial companies can land on the moon. So they created a program called the CLIPS program, Commercial Lunar Payload Service Contract. 10-year contract, $2.6 billion. You get in, you get the right to hunt and bid. So we won that. Oh my God, that was amazing. 9 vendors won a seat at the table to bid on flying complements of NASA payloads to the moon. Now we would own the infrastructure, right? We would own the complete service, and we would return the data back to NASA. That's what you saw in our mission control here in Houston. We're sending data back to the payload operations centers around the world right now as we're talking. So first task order came out, boom, we win a shot to fly the first mission. That's our mission going up November 16th. We ship to the Cape, and we'll launch off of Pad A. We ship to the Cape October 5th. We launch off of Pad A on November 16th of this year.
How hard was it to get a shot at it in the beginning there? Because you said you got an opportunity to do this, and then you won again in order to do the first mission, right? So I mean,
so we got a seat at the table, and everybody who got into the contract got $25,000 task order to write a plan. I mean, it was nothing. It wasn't the thing. But when you win a task order, you have the chance to return the United States to the moon as a company for the first time in 50 years. That was huge. Well, then we're going along. Another task order comes out, we win that. Another task order comes out, we win that. So now we have 3 missions to the moon. So now we're resilient to failures. We have an opportunity to actually be successful as a business. So that's kind of how it all got started. And now here we are with our first mission complete 4 years later, with the lander here at Spaceport Houston at Ellington Field, complete, doing integrated payload testing with our mission control. And we built a lunar data network around the world using radio astronomy dishes that usually stare into deep space, but when the moon's in view, they can't because of the background noise the moon creates. So we point the dishes at the moon, and we communicate line of sight to the moon and bring that data back to mission control. So we not only can fly to the moon, we have the first ever lunar distance network that's fully commercial as a necessity because you have to build it all commercially. So quite innovative. And so we're very excited about that mission.
And the mission specifically is to do what? Are you going to land on the South Pole?
Yeah, we're going to land on the South Pole region of the moon. Imagine landing not exactly on the South Pole, but in Antarctica. And what we're going to do initially is mainly navigate ourselves to that location, observe the dust plume as the engine comes down and disrupts the surface. What does that look like for the future? Measure the background, electromagnetic background of the moon itself. We don't have a good understanding of that. Do a couple of navigation payloads using laser Doppler LiDAR and also an RF experiment called LUNR, which uses RF to help with navigation. So just a few payloads, NASA payloads, and then I have a few commercial payloads on it. And then the next mission really will be closer to the actual South Pole. We'll land on a place called Shackleton Ridge, and we'll drill for water ice. And from there, we'll drill down about 1 meter, and we'll read the tailings pile with a mass spectrometer and determine what the constituents of that core drill is going to be, and is there entrained water ice in the soil, and discover for the first time water on the surface.
Why is that important?
Well, it's a resource that allows you to have a sustained habitation or a habitable presence on the moon, because you can make consumables that astronauts need, and you can also use it to make propellants for something like oxymethane, which is what our propulsion system's all about.
Interesting. And then a little bit about the extreme environment. You were telling me earlier, the temperature swing. So it actually swings from
Oh yeah, no,
like Houston temperature, I think, this
close
summer.
to it. It feels like,
Yeah.
boy, the moon is such a hostile environment, and it is not an easy descent to the moon. But just the temperature, thermal environment in the sunlight, you go from 250 degrees Fahrenheit to when, as soon as the Terminator comes across or you're in the shadow, you're at minus 280 degrees Fahrenheit. That 500 plus degree temperature swing is just brutal on electronics. It's brutal on structure. It just is a really tough thing to engineer yourself around. So, but that's the challenge. That's what we accepted. That's what we stepped up for.
So you've had a lot of successes this year. You were an EOI finalist, and I was also, but you won. Congratulations.
Yeah, here's the both of us.
Yeah. Go for it next year, but literal moonshot. So I like that. And then you also went public as a company, and not too long ago, right? And tell me a little bit about ringing the bell.
Wow. Yeah. I have a little trophy back here, opening bell. Lunar, the coolest call sign on the NASDAQ ticker, LUNR. And I think it was one of the great life experiences that I've had, is to be able to build a company from a napkin and take it all the way to a public company as a founder and CEO. And to see, the vision just come to life over the past 10 years. It was really, really an exceptional event. The NASDAQ does it well. And what I wanted to do was I wanted to put the heat and light on what we were trying to do as a commercial company. I wanted more people to be aware of space exploration, and that we were setting out as a business to commercialize cislunar space. So what we got to the point was we were very capital efficient as a business. But when we won the 3 missions, suddenly there's resilience in the business. We had an ability to try and try and try again, should we have failed. Unlike some commercial lunar companies that have one lander, they try it, they fail, they go bankrupt. I didn't want that model. So what I wanted to do was build some resilience in the backlog of work that we had, the missions we had, build diversity in the revenue streams. I could sell communication services now, right? Because we built that ground network. I can sell orbital services to drop satellites off into exotic orbits that's never been done before, because we don't fly out that far commercially. That's another revenue stream. And so had these ideas about how to diversify and build a more robust, modern aerospace company that could serve as a national asset that is important for the United States to have. And so how do I build all that in? The choice was go public and let more of the world see what we were trying to do and why, in the interest of the United States and all of humanity around the world. So that was the motivation behind it. It wasn't just capital driven, because it was the worst time to do a D-SPAC. They said, this is the last space SPAC you'll see. You know what they said after we went public? It's the last best SPAC, as our stocks shot up.
So part of the IPO is just to raise awareness about space exploration, besides, of course, the funding and everything that you get from that.
Yeah, it was. It really was. I wanted more people paying attention. And as a result, they are. They can watch it. They can get engaged. They can participate with us. So it was one way to do more democratization of space. We just get it to more retail investors. And the retail investors seem to like us.
We had such a head start on the moon, 50 years. Right. And now all of a sudden we're worried about China. Right. I mean, we could have owned it. Right. And any thoughts on why the moon hasn't been important? Because for me, from the outside, I would think, well, if we're trying to practice and learn more about harsh environments and living on a place that's not the Earth, why not do it somewhere that's relatively easier to get to versus Mars? right?
Right.
And why hasn't that been something of interest to NASA in the past?
I've given that some thought. I think, what was fantastic, and also hard was during the Apollo program, which included Mercury, Gemini, and Apollo. Right, there was a national imperative, a security imperative that said we are in a Cold War, and let's put the whole power of the nation towards this goal of landing a human on the moon in a decade. John F. Kennedy's speech at Rice. That was a national imperative, and we did it. Since then, there really has not been a national imperative. It was, hey, let's do some space systems and kind of go along as we can afford it. And you know where you go when you go along as you can afford it, you don't go very far. There's been competing dollars for a fairly flat appropriations within NASA, for competing dollars for planetary science, for human space flight, for heliophysics, for aerosciences or aerodynamics. All of the competing dollars is spread around like peanut butter. I think what's changed now is there's a new national imperative. And the National Space Council or Security Council that said the moon is of strategic interest says what? The United States must spend dollars to build a sustainable presence on the moon. As soon as that happened and they opened it up to commercial business, now you get the competing companies innovating, right? Give us the ball. We'll run with it. We'll take on a technical challenge that's over-constrained schedule-wise. It doesn't have enough dollars with it. We'll take the risk. We'll leverage private capital and extend the public dollar. And that's what's happened. In 2018, when we started to think about going to the moon as a company, Intuitive Machines, there were 0 lunar landers being built in the United States. Today, there's over a dozen. Isn't that amazing?
That is amazing.
That instigation, that little bit of funding from the federal dollar has really brought to life what the power of the U.S. economy is. And all those constraints drive innovation, create inventions, force you to solve problems. When you're hit with a roadblock, you can't just go back to the well for more money. You've got to solve that problem.
There seemed to be like a shift between, in the past, 50 years ago, government had to do the whole thing. And at some point, someone realized, well, government could be more of an enabler, right? And enable companies like SpaceX and Intuitive Machines and kind of be a gateway and allow that collaboration and innovation and entrepreneurial spirit really to grow and blossom. But I don't know exactly at what point that happened or changed. Did you see anything there? Like what was the shift there where they're like, hey, this might be a better idea? Because there was a lot of resistance to SpaceX.
Oh, yeah.
And Elon's talked about that in the past. But I think that it really was a breakthrough and an opportunity for other businesses to do the same thing, right?
Yeah, I think the change occurred. You saw in the Apollo program, the Cold War driven monolithic programs built by governments, right? And then you saw a shift from there to the next logical step was, can we do international cooperation? And you came up with something that was wonderful, was the International Space Station, right? Almost won a Nobel Peace Prize in and of itself for putting all these countries together that build a place to live and work in space in harmony, right? But that was still arm's length, where you build a module, I'll build a module, we'll identify the interface and we'll bolt them together. It was not fully integrated spacecraft among the international partners. Well, now you see when SpaceX came in and others, even Boeing, Starliner, and Northrop or Orbital's cargo resupply, you start to see the commercial company coming on strong and building some capability and say, wait a minute, the days where we're in this flat spot, I talked about, national imperative. Well, then we got into a period where we got comfortable with big aerospace, getting cost plus award fee contracts to keep a program sold across administrations. Because if they go 4 years and get cut and you start again, 4 years and get cut.
Which is what was happening back in my day.
Exactly, right? 23 programs canceled in 25 years, some metric like that.
That's
in
crazy.
the 2000s, right?
Talk about killing innovation.
So now you say, okay, that was to keep them sold because we really didn't have an imperative. Now, when you see the success of things like the commercial cargo program, when it started, it was visceral reaction to commercial in the beginning, like you say. Then as success came on, well, let's try this. You get more for your buck. Commercial cargo to resupply International Space Station commercially, commercial crew to resupply with, get off of the Soyuz and have commercial companies do it. Hey, there's something to this. And that's what's changed. And now if somebody, and the person or organization that actually embraced this, because there was such a negative reaction, was the head of science, science mission directorate, who looked back at human spaceflight and said, let's do science missions where I can get more science if I let the commercial sector build the infrastructure. That turned just like that. And that happened, started in 2017 and 2018, and that's where the CLIPS program came from. Now the CLIPS program in NASA will serve several mission directorates, the technology, the science, the human spaceflight, all of them, because this is such an efficient way to go do things.
So more collaboration between government and corporate and business.
That's right. That's right. And we'll take risk, as a business and compete. And because of this risk we're taking, we have to innovate. And I think we're getting some, just fantastic capability in this country as a result of it.
And there's still one missing piece, which is funding.
Nice segue.
Tell me a little bit about that.
Yeah, funding has been difficult. Macroeconomics, if you look at the markets today, are such that, it's tough to raise capital in these markets. Inflation, threat of recession, interest rates going up. There's dry powder sitting on the sides and then we saw a few large investments in aerospace just fail. And so there's a little bit of skittishness there. So it's been tough from a standpoint of, you look at how all the SPACs have performed in space, aerospace SPACs. You look at where private equity investments are coming, more and more going overseas to look for overseas money, right? So the time is tough. I think if I bring it back locally here, we had trouble in the early days of the company trying to raise money in Texas, in Houston.
For space.
For space.
Where do you think it would be?
In Space City, you can't raise capital for space. Why was that? And so I'm pretty outspoken these days about what would make the space economy grow exponentially in Houston and in Texas, which Texas is doing some amazing, innovative things all over Texas for space that I don't know, people have all connected those dots. We got the Starship down in Boca Chica. We've got engine testing going in McGregor. We've got lunar landers going at Spaceport Houston. We've got commercial stations. We've got spacesuits all at the Spaceport Houston. Just amazing things going on. But when you go into Houston and you say, hey, I want to raise capital for space, they're like, hold on. We formed this company, this city on oil and gas. Wildcatters made their money, and now their grandchildren are stewards of that money. And that money goes into shopping malls and things that keep that fortune preserved. Where's the wildcat spirit, right, that's needed for space exploration? And I think it's up to us as entrepreneurs and as leaders in the space community, kind of find a language that resonates with investors and create our own financial models in the city of Houston that says, let's bring this money to bear in a way that can actually grow space, commercial space, manufacturing for aerospace here in the city and this state. What's been great, I attended a thought leaders exercise downtown this morning. And there's been now the Space Commission by the state that's well funded, that's looking for where should we deploy that capital. That's supported by our senators. You see Johnson Space Center with the Artemis program, and you see commercial startups at the Spaceport, and you have Bay Area Economic Partnership, Greater Houston Partnership, Rice University, the ION. You have all these different entities that are all looking for economic development. We have the funds, we have the purpose, we have the mission. What we need to do is find a way to bring that capital here. I think this city, I studied entrepreneurship a little bit in Silicon Valley. And a lot of people come and want to think about entrepreneurship in Houston, and they want to replicate a model like Silicon Valley. No. Houston has its own identity. Where else can you build a large business? Where else do you have C-suite talent that can come lead a large business? You have managerial level that are exceptional at leading large teams. And you have doctors and lawyers and physicists and astronauts and geologists and chemists and all the people you need here. It's just a recipe for success. If we could just get a focus on bringing the right venture capital, bringing the right private equity capital, and maybe that's, I'd like to also bring the right legal, what do you call it, policy, legal, regulatory piece into Space City, into the Texas area where we own that, right? Treaties, policy, that doesn't have to be in Washington. That can start here and be incubated and to benefit all of the space economy.
Well, tell me a little bit about your next milestone for Intuitive Machines. You have something called a Super Bab, and I want to know more about what that is.
Super Bab.
Super Bab.
That's the super badass building.
Okay.
That's, Jack Fisher. He's our resident astronaut and wizard of just about anything he puts his mind to, named it the Super Badass Building. What we did was we created, we worked really hard to help the city, to help the airport authority, to help Mario Diaz and Arturo Machuca create Spaceport Houston at Ellington Airport by putting together, we're going to build spaceflight hardware at Ellington in your envisioned spaceport. And there's an old building there that used to be a Boeing building where they build docking systems and crew capsules and stuff. And they vacated that building, and it became like the first real spaceport building. It was under need of a new roof and everything, a leaky building. So I need a place to grow the company and to do manufacturing and to make things. All the things that are in our imagination we wanted to make. And it's making real space stuff. So could we get any incentives from the city and the Houston airport system? At the same time, San Jacinto Community College was saying, we need a space. We want to grow a tract to train aerospace technicians and engineers. And they did that in the petrochem area, and they did that in several different areas at San Jacinto. They've been successful at creating these institutes. And so they came up with the Edge Center. And so we went into this one building together between San Jacinto and Intuitive Machines. And we started working, and I talked about this a little bit. I joined their advisory board, and I helped them create, with the industry advisory board, this tract for retooling oil and gas people and taking graduates from high school and putting them into technician certification programs. How do you become a machinist? How do you do harnesses, electrical harnesses, electronics? What do you do with composites? And they would get a certificate. And then I would, as Intuitive Machines, give them internships and then jobs. And it was onesie twosies. It was a few. But we were building spaceflight hardware. We were training a workforce, and we're giving them jobs. And there was a facility there. And I think that became the engine that said, this is the first step to a real functioning spaceport in a metropolis, which everybody thinks a launch port. Mario Diaz and Arturo had a different view of what a spaceport could be. It's a hub for R&D, for collaboration, where universities and companies come together and socialize and do business together. And so as a result of that, they opened up a tract of the first 90 acres, and they have 400 acres to expand. And through working with the Bay Area Economic Partnership and Greater Houston Partnership and others, and the city council and the mayor, to create incentives for companies to move in. And what really inspired them is they offered that to other companies who then said, nah, you don't quite have the workforce, or no, you're not quite big enough. We said, we want to go in there. Collins said, we want to go in there. Axiom said, we want to go in there. And so we negotiated some incentives and came out with a building, 110,000 square foot custom built building for Intuitive Machines that has office space, it has lab space, it has high base space and cranes to move our landers and spacecraft around. And we're getting ready for ribbon cutting on September 29th, where the building is essentially complete, mostly. I mean, we're going to get a temporary certificate of occupancy to start moving in. But the building's got there. And we'll do our first mission from the old building and the mission control from here. But after that, we're moving the whole company into this building. It's so exciting. It's just the next level of growth on the horizon for Intuitive Machines.
Wow, congratulations.
Thank you.
If it's open to the public, I'd like to go, but how do I get an invite?
It's not open to the public, but I'll take
I want to go to the ribbon cutting, All right, well, good. Well, Steve, this has been super interesting. I'm really impressed with what you're trying to do and want to continue to help supporting you in whatever way we can to do that. I've got my space shuttle socks on today in honor of my intern days at IBM and NASA, and I have some socks for you today.
Awesome.
I don't know, so obviously space related.
Excellent.
So a few more planets than the moon, but we'll get there someday, right?
Hey, well, my new vision is to move out into the solar system beyond the moon, and I'll wear my socks for that on.
Perfect.
Maybe I'll wear these on launch day too. Thank you for that, Chris. I really appreciate the time.
Thanks for being on the show.
Yeah, I enjoyed it.